I'm going to do a couple of extra examples because anytime I say trig, everybody gets all worked up. So I'm just going to do a few extra examples here, some integration and some derivatives both, just to keep us all practicing a little bit more, especially since there was only just kind of a couple examples of each. This way we can practice a little bit more, and hopefully you'll feel more comfortable going into this. Okay, so the first one I'm going to do is 7.5.83. It's an integral from 0 to 3 halves. Let me look at my paper here. I'm getting off on my lines. Here it is. Dx over the square root of 36 minus 4x squared. First of all, is it a u sub? Because that's always our go-to method no matter what section we're in. No, and it's not a u sub because there's no x on the top. Good. This is a 4x squared. In order for it to work out for a u sub, I would have to have that extra x up here. So negatory, good buddy. But I see I have a square root. I see I have a number. And I see I have something squared back here. That is my tip-off. Those are the defining characteristics to tell me I'm doing inverse trig. Yes. Okay, good. Now I want to identify which one it is. It's sine. Nice. So a is equal to 6. And x is that 2x. Now, plug it in. Remember, sine, inverse sine, is just x over a plus c. I don't have the 1 over a in front because it's sine. However, inverse sine here of 2x over 6 plus c, because it's not secant, so I can just straight up put this 1/2 in front. You could also go through the process of u sub, but I wouldn't waste my time, right? Don't waste your time if you don't have to. And you guys are probably yelling at me, and I appreciate that because this is a definite integral. Tune in, Bradley. I know. So with my definite integral, now I'm going to plug this stuff in. So I've got 1/2, and I'm going to just leave that out front because I don't want to mess with it. And I've got inverse sine, and I'm going to keep this 2 here just because I see this is 2 times 3 halves, and it cancels out over 6 minus the sine of 0, inverse sine of 0. Squeeze this up a little bit. I see those cancel, and I see 3 goes into there 2 times, so you really end up with a 1/2 here. So what angle measurement gives me a sine of 1/2? Sine of 1/2 comes over here. It's actually pi over 6, isn't it? Because that's the square root of 3 over 2 and 1/2. My y is 1/2. So if this is pi over 6 minus, what's the sine of 0? 0, right? Because I'm saying what angle measurement is going to be 0, and that is 0, gives me a sine of 0. So minus 0. So I end up with just pi over 12 here. All right. Look for those patterns. If you can do a u sub, do it. If you can't, then don't. You look for the pattern then and see what you've got. Do I have room here? Nope, not really. Let's go to the next page. Okay, let's do a derivative. 7.5.67. Find the derivative. So I have f of x is equal to the cosecant, inverse cosecant here, of the tangent of e to the x. Ah, chain in a chain. Love that. Chain, chain, chain. Because I have outside function, inside function, right? We got a double chain here. Oh man, this has got to be your best day ever. I get that. Let's do it right now. Remember the derivative of cosecant? Yep, same thing as secant except with the negative. So this is going to be negative 1 over, and remember it's the inside function as at x, so tangent of e to the x, oops, absolutes, the square root of tangent of e to the x squared, so this is tangent squared of e to the x. I don't want to write all that in there. But then I chain this, the derivative of the outside. What's the derivative of tangent? Secant squared. If you don't know that, learn it. Times the derivative of this inside because it's that double chain. And the derivative of e to the x we now know is e to the x. And then you just put it all together. It looks awful messy, but it just is what it is. Negative e to the x secant squared of e to the x over the absolute value of tangent of e to the x square root tangent squared e to the x minus 1. So that answer looks a little wonky donkey, but it does the trick. Okay. One more. We got time for one more. Because I want to do another integration and something that you look at and you go, what? So we can do it together. So hopefully you're more comfortable doing it on your own. 1 to the square root of e dx over x square roots of 1 minus the natural log of x squared. Now tell me things that you see. Ooh, so which one do you think this is? It looks like a trig, doesn't it? Yeah, this x in front totally looks like a secant. However, there's not a secant up front. I mean, the variable isn't up front. The variable's in the back. That's a sign trait. Right? So that's what makes this one kooky. All right? So what else are you thinking you could do? Sure, let's try a u sub. And remember, with a u sub, you always want to try the inside weirdo stuff. So this instance, that would be the natural log of x. That is what's squared underneath the radical. And look at what's happening here. 1 over x dx. 1 over x dx. Cool, right? Natural log doesn't go away, folks. It's hanging on forever. We'll get our bounds here in just a second. But now du is going to be over the square root of 1 minus u squared. And that looks like a pattern we've seen before. Now change your bounds. At x is equal to the square root of e that I'm looking at. Remember, if I have something that's to the square root, that's the same thing as to the 1/2 power. So if you plug this in, that would be u is equal to the natural log of e to the 1/2. Natural log and e cancel out, and I'm just left with the 1/2, right? Get that algebra in there. At x is equal to 1, remember the natural log of 1 is 0. There's our natural log here at 1, that is 0. Okay, this is a good one. I told you it was good. This is going from 0 to 1/2. Now it's straight up inverse sine. You just had to do a little u sub first. So I've got inverse sine, and then I know here x is u and a is 1, so that makes it easy. So I just have the u. We changed our bounds. Keep them changed. And look at this, guys. You don't want to try to go back putting something like natural log in and subbing this in. That's crazy talk. Change those bounds. Make your life easy and move forward. Inverse sine of 1/2 minus the inverse sine of 0. Where is sine 1/2? Pi over 6. Square root of 3 over 2, 1/2. So I've got pi over 6 minus 0 is just pi over 6. All right. Practice these. We'll practice some more in class also, right? We're totally going to practice. Look back over these and give them some good practice, and You can do this.